Prove that sigma n is a multiplicative function. Proof: let a and b be the two co-prime positive integers. If a is equal to 1 and b is equal to 1, then ab equal to 1. Therefore, sigma a is equal to sigma 1 equals to 1, sigma b equals to sigma 1 equals to 1, and sigma ab equals to sigma 1 equals to 1. So sigma equals to sigma b equals to sigma a into b equals to 1. Also, sigma a into sigma b equals to 1 into 1 equals to 1 equals to sigma ab, which shows that sigma ab is equal to sigma a into sigma b. If a is equal to 1 and b does not equal to 1, then sigma a into b equals to sigma b, which implies sigma a into b equals to 1 into sigma b, which implies sigma a into b equals to sigma a into sigma b, because sigma a equals to sigma 1 equals to 1. Similarly, if a is not equal to 1 and b is equal to 1, then sigma a into b is equal to sigma a into b. And if a does not equal to 1 and b does not equal to 1, then a is greater than 1 and b is greater than 1, so that a is equal to p1 raised to power a1, p2 raised to power a2, so on, pr raised to power ar, and b is equal to q1 raised to power b1, q2 raised to power b2, so on, qs raised to power bs, where p1, p2 and so on, pr and q1, q2, so on, qs are distinct prime. Therefore, a into b is equal to p1 raised to power a1 into p2 raised to power a2 and so on, into pr raised to power ar into q1 raised to power b1 into q2 raised to power b2, so on, into qs raised to power bs, which employs sigma a into b is equal to p1 raised to power a1 plus 1 minus 1 upon p1 minus 1 into p2 raised to power a2 plus 1 minus 1 upon p2 minus 1 into so on, into pr raised to power ar plus 1 minus 1 upon pr minus 1 into q1 raised to power b1 plus 1 minus 1 upon q1 plus minus 1 into q2 raised to power b2 plus 1 minus 1 upon q2 minus 1, so on, into qs raised to power bs plus 1 minus 1 upon qs plus 1, which implies sigma a into sigma b. Hence, each case sigma a into b is equal to sigma a into b, which shows that sigma n is a multiplicative function.